Okay, so today we're working on day 3 of our trig notes, trig functions of general angles by finding value on the unit circle. By now you should be pretty adept at the unit circle, and you'll be taking a big quiz on the unit circle tomorrow. 5-minute timed unit circle. You must fill in all the blanks, including radians. And so that's what we're going to be working on tomorrow. So when you're evaluating trig functions for a given point, what you're really going to be focusing on is where your, what quadrant you're in. So let's kind of go through and remember that in our quadrants, you have positive, positive coordinates. Here you have negative, positive. Here you would have negative, negative, and then positive, negative. Oops. So if you can label those out, then when you're given a set of coordinate point, you can already determine what quadrant that's going to be in. So, example, find the exact value of the 6 trigonometric functions of theta if the terminal side of theta contains the point 8, negative 15. So here you've got your 6 trig functions, which you should have memorized by now. If you don't want to use the y over the radius or the x over the radius, you can certainly use opposite and adjacent. We can quickly write those out up here. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant would be the reverse, the inverse of sine, so that'd be hypotenuse over opposite. Secant would be hypotenuse over adjacent, or the inverse of cosine. And cotangent is adjacent over opposite. Okay. Remember that your degree is always the one that's formed by wherever the terminal side is. Okay, so if I were to sketch out the point 8, negative 15, 8, negative 15 would be down in this quadrant here. So if I went over 8 and down 15 and made a triangle of that, so this would be my theta, that angle that's created there. So this would be 8, this would be negative 15 of that angle. And we need to find our sine, cosine, cosecant, secant, tangent, and cotangent. So our sine is going to be, so we need to figure out where our hypotenuse is of this first of all, because we're going to need that in every single equation. So using Pythagorean theorem, let's go ahead and do 8 squared plus, it would be negative 15 squared. That's going to obviously bump out to a positive because we're squaring it. You're really looking at the length of the side, so you don't need to worry about the sign at all. It's a length. You can't have a negative length. So you've got 64 plus 225, which gives us 289, and the square root of that is 17. So our radius of this circle would be 17. Now once you've got your 3 measurements, now you're just going through and doing your ratios. So our opposite over hypotenuse would be negative 15 over 17. Cosine would be adjacent over hypotenuse, so 8 over 17. Cosecant would be the inverse or the reciprocal of that, so of sine, so 17 over negative 15. Secant is the inverse of cosine, so 17 over 8. Our tangent would be opposite over adjacent, so negative 15 over 8, and cotangent would be the reciprocal of that, which is 8 over negative 15. Okay. I know this says 3 for our second example. Find values of 3 trigonometric functions. Go ahead and do all 6. It's good practice for you. So repeat what you did here on the first example using the point 5, negative 12. And then we will then come back and check your work, please. Okay, so 5, negative 12 would be positive, and down 12. So this side would be 12, this side is 5. The angle that's created there would be our theta. Okay? So again, we need to find, using Pythagorean theorem, we would have 5 squared plus 12 squared equals c squared. 25 plus 144 is 169. Take the square root of that. So our radius would be 13. So sine, you should have gotten 12 over 13. Cosine equals 5 over 13. Cosecant equals 13 over 12. Secant equals 13 over 5. Our tangent would be 12 over 5, opposite over adjacent, and our cotangent would be 5 over 12. Okay? Okay, so a quadrantal angle, an angle whose terminal side lies on one of the coordinate axes. So this is where you're going to have it 90, 180, and 270, or back at 360. Those would be the ones that end each quadrant. That's why it's called a quadrantal angle. Okay? Flip to page 2. So some of your quadrantal angles would be what? So you would have 0, 90, 180, 270, 360. We also talked about angles that are coterminal. So if you went around the horn one more time and hit those numbers again, you would have 360, 450, 540. These would all still be quadrantal angles because they end on one of the axis lines. 630 and 720. Okay, and I could keep going as many times as I wanted to go around the entire graph. I could do that. Okay, find the exact values for values of the 6 trigonometric functions of theta in the standard position that measures 180. So that's where I'm here. So let's remember what our coordinates are here. So I'm at -1, 0. Okay, we always assume a radius of 1. Okay, and if we go back to our unit circle, let's think about our unit circle and what the sign of, or to our chart that we made. Our sign at 180 is 0, right? That's our coordinate here. So our sign of 180 would equal 0. Our cosine equals -1. So when we do 0 divided by -1 for our tangent, that would also equal 0. So what you have to be careful about is when you take the inverse of those, right, you have the secant. Now you've got a cosecant inverse of 0 is still 0. The secant is still -1. But our tangent, you would now have -1 divided by 0, which you cannot have. So our cotangent is undefined. Okay. If you had a question all about that, you still got this chart that you can use, and you should have this chart filled in by now. So, and if not, you can finish that when you're done with these notes. Okay, so going down to the bottom, so for any angle that's not quadrantal, we have reference angles, and this is also something we went over with our chart here. We talked about in your first quadrant, this is kind of your control group. You can easily figure out your sine, cosine, tangent, cosecant, secant, cotangent of all of these angles in the first quadrant. The only thing that changes in the second, third, fourth quadrant is whether your signs are positive or negative, depending on which quadrant you're talking about. So if we look at a unit circle, so when we have a completed unit circle, but we have our reference angles, and that's when you're kind of using this first quadrant as your base. And then seeing if I were to fold that over either across the y-axis or across the x-axis, where would that same angle be located? Okay, so for our first example here, we have 160. Well, 160 on the unit circle would be about here. So directly across, it would be there. So the easiest way to do that is determine the difference between 160 and 80, which would be 20 degrees. So its reference angle, 160, was about here. Then directly across over here would be 20 degrees. Okay? I want you to go ahead and find the reference angle for these remaining three. Hit pause, check your work, and then come back and check. Okay, so at 110, you would go in the clockwise direction, you'd be here, and plus another 20. So if we were going counterclockwise, we would go this way plus another 20. Oh, wait, can we do that? No, we can't. We need to stay in this quadrant, right? So you're going to do 90. It's 20 past our 90 degrees, so this is going to be 20 in front of our 90 degrees in the reference angle. So that would be 70 degrees. Okay? Its reference point would be over here at 180. So 180 minus 110 would give you 70. Okay? 275 would be 90, 180, 270, and 5. So that would be just off of the y-axis at the top. So it would be 90 minus 5, which would be 85 degrees. Okay? In radians, you can either convert that to radians or just know here you have pi over 4. This is 2 pi over 4. About there would be 3 pi over 4. Okay? So its reference, oh, sorry, and we have a negative there, so I didn't see that. So we did the same thing down here. You would have negative pi over 4, negative 2 pi over 4, or pi over 2, negative 3 pi over 4. So it's actually, its reference point is going to be here. So it's like you have 2 pi minus 3 pi over 4, which gives you pi over 4. So its reference point is pi over 4. Okay, and you can use your unit circle for the last 4 at the bottom you want to, or you can use the chart. If you've got this chart done, these last 4 questions will be remarkably simple for you. If not, go ahead and use your unit circle. Use it as a practice for your quiz tomorrow. Go and check, fill in those 4 answers, and then come back and check your work. Okay, so cosine of negative 60 would be down here. Its reference point would be 60. That cosine is 1 over square root of 3, and you rationalize that out as square root of 3 over 3. Sorry. Rewind. Reference angle is fine. Here's negative 60. That is 60. Our cosine of 60 would be 1/2. Now, cosine in the 4th quadrant does not change signs because here we have positive, negative. So our cosine of negative 60 is still 1/2. Okay, sorry about that. Okay, cosine of 5/4 has a reference angle. So 5/4 is all the way here plus a 4, right? So it's got a reference angle of pi over 4. The only thing that changes now is this is negative, negative. So cosine of 5 pi over 4 is going to be negative square root of 2 over 2. The amount you're going over on the x-axis to get down to that point. Okay? Okay, cotangent of 150. So if I'm going 150, but now I'm going clockwise, I'm at 90, almost here. So I'm at, if I went around the horn there, its reference angle would be 30. Okay? So tangent of 30 I looked at my 30-degree angle, and it's 1 over square root of 3 or square root of 3 over 3, right? But we're looking for the cotangent of that. And my tangent here, now if I just looked at the 150 and found my tangent at negative 150 would be negative square root of 3 negative square root of 3 over 3. But then when I have a negative negative, that's going to bounce out to a positive. So its tangent's going to be the same. So the cotangent is going to be 3 over square root of 3, which of course you have to rationalize out. So you get 3 square roots of 3 over 3, or just square root of 3. Again, that will be on this sheet that you have here. So there's our square root of 3 over 3. Cotangent would be square root of 3. Because your sine and cosine are both negative in the third quadrant, your tangent and your cotangent would still remain positive. Okay? All right, so negative, and if you want to practice putting this back into radians, this would be cosecant of negative 2 pi over 3 times 180 over pi. Okay? That goes in 60 times, so it would be negative 120. So that would be here and then here. So its reference would be 60, okay? And so cosecant is the inverse of sine. So our sine of 60 is square root of 3 over 2. So the cosecant would be 2 over square root of 3. We've got to bump that out to 2 square roots of 3 over 3. But the cosecant here is going to be negative because our sine, yes, because our sine is negative. Going down is negative. So our cosecant of negative 2 pi over 3 will be negative 2 square roots of 3 over 3. Okay. All right, so that's the notes for day 3. And Monday and Tuesday we're going to be working on a really fun Ferris wheel project. So this will be helpful information for you for that project. Don't forget, got a big quiz. Make sure you can recreate this and make sure you include what's positive, what's negative in each of these quadrants. You should be able to repeat everything on this sheet. So you can take a screenshot of that, memorize it, practice it. There were blanks given out in class. You can easily just sketch it out on the back, make a circle, sketch it out best you can. Okay? Good luck. See you tomorrow. Thanks.